to show you how to solve systems of equations by graphing. And here's an example of one. I'm going to give you 3x plus y is equal to 11, and x minus 2y is equal to 6. I'm going to show you how to set up that equation in the form of y equals mx plus b. I'm going to show you how to make a table of values, and we're going to plot the two lines and see where they intersect, and that will be our solution.
3x plus y is equal to 11. We're going to set it up in the form of y equals mx plus b. That means we have to leave y on the left side of the equal sign. We're going to bring the 3x to the other side. And when we do that, we change its sign. So we end up with y is equal to minus 3x plus 11. Then we're going to make a table of values, such as I have right here, x and y. And if we substitute in 0 for x, then minus 3 times 0 is 0, and therefore y is equal to 11. And we can substitute any other number in for x and determine what y will equal. I chose 2 for x, and so negative 3 times 2 is negative 6, plus 11 will give you 5. Okay, we're going to plot that. Okay, but first we're going to look at the other equation. X minus 2y is equal to 6. We're going to set it up in the form of y equals mx plus b. First step was we'll just bring the x over, change its sign, so it becomes minus x plus 6. And then we're going to divide through by minus 2. The minus 2 and the minus x will make it a positive. And the negative 2 divided into 6 will give you negative 3. And then we're going to set up a table of, so our equation can also look like this. Y equals 1/2 x minus 3. We can set up a table of values like we did before. When x is 0, y is negative 3. We have that. And I also chose 2. When x is 2, y is going to be negative 2. The 1 minus 3 is negative 2. So now we'll plot the x-axis.
Okay, I've put on values for the x and y axis.
Okay, first we'll do the 3x plus y is equal to 11. So I've got 2 points right there. I've got the x is 0 and y is 11, x is 2 and y is 5. Alright, so let's put those things on. 0 and 11 would be right here, 10, there's 11, so put a little dot there, and 2 and 5. Okay, so 2, and go up to 5, and dot that. Okay, now I'll draw a line through it. Okay, and there I've drawn a line, and I put arrows at the other end, because the line means that it is extending further at both ends. Let's put the other line on. Okay, the other line was x minus 2y is equal to 6, or y is 1/2 x minus 3, and those are 2 points, 0 and negative 3, 2 and negative 2. Here are the points, 0 and negative 3, and 2 and negative 2, so I'm going to draw a line through those 2 points. Okay, and here I've drawn in the other line, and you can see that at one point they intersect at here. This point here corresponds to 4 and negative 1. Now to verify that this is a solution for this line here, y equals 1/2 x minus 3, is I can substitute this in for x and this in for y and see what happens. And when I substitute it in, there's negative 1, 1/2 times 4, and then minus 3. So let's see if the right side, this will produce 1/2 of that is 2 minus 3. And you can see that we're going to end up with -1 on this side, and of course we still have -1 on this side. And so we can say that the left side is equal to the right side. Therefore, this equation satisfies that point. Let's try the other side. So I've rewritten y equals -3x plus 11 here, and we're going to substitute in 4 and -1. And so for the y is -1 is equal to -3 times 4 plus 11. So that's going to equal -12 here plus 11. And we're going to see that it's going to equal -11 or -1 on both sides. So again, we have, left side is equal to the right side. So that means that that is the solution to our two equations, 4 and -1.
So we have seen that if you take two equations, such as 3x plus y is equal to 11, and rearrange it to y is equal to -3x plus 11, and another equation, x minus 2y is equal to 6, and rearrange it to y is equal to 1/2 x minus 3, make a table of values, plot these two lines, and at the intersection of these two lines is the solution set. And in this case it turned out to be 4 and -1. And you can check each equation to see that the right side is equal to the left side to prove that you do have in fact found the true solution.